right, so we're going to go through the lesson master. Let's see. Evaluate, it says without a calculator. 64 to the 1/2 means the square root of 64, which I know is 8. Number 2. The cube root, because it's to the, now wait a second, this negative sign is not in the parentheses, so this negative goes here. And the 64 is the only thing that's the cube root's being taken of. So I end up with a negative, and the cube root of 64, I know is 4, because 4 times 4 is 16, and 16 times 4 is 64. Now number 3 says take the cube root of negative 64. So I know it's going to have to be negative, and it's going to be negative 4, because negative 4 times negative 4 times negative 4 would give me negative 64. The fourth root of 64, got to think about this one. I've got to think how I could rewrite this. There isn't an exact answer here. This one's extra challenging, if you will. I've got to somehow then simplify this. I know the square root of 64, and I know the cube root of 64, but there isn't actually just a straight up fourth root of 64. So I've got to think of another way to write 64, and I know that 2 to the 6th power is 64, because I know 2 to the 5th is 32, because I've done it so many times, that then if I just multiplied one more time, I'd get 64. So if I took the fourth root of 2 to the 6th, that's like 2 to the 6/4, right? Which is 2 to the 3/2 in simplest form. So I could write it like that, or I can say that it's the square root of 2 cubed, or the square root of 8. But I know I can simplify the square root of 8, and that would be the square root of 4 times the square root of 2. So I end up with 2 square root of 2. Wow. That was lots of thinking that I had to do. If you can do a problem like number 4, you're going to be good to go. Let's see, in 5 and 6, assume that all variables are positive and write without a radical sign. So this power is 1 and this root is 5. Remember that we're always going to do power over root. So it's p to the 1/5. For 6, it's going to be 3 to the 1/3, t to the 3/3, which becomes 3 to the 1/3 t, because 3 over 3 is 1. Now in 7 through 10, we're going to write using a radical. So we're doing the other direction this time. So this is going to be the fourth root of v to the 1st, which I can just write as v. Number 8, notice the 7 is not being raised to the 1/5 power. So it's 7 times the 5th root of n. The 7 would have to be in parentheses to have that exponent be applied to it. Number 9, negative p to the 1/3. Notice the negative is not in the parentheses, so it's going to be negative the cube root of p. So a little closer. You can see the problems a little better. Don't know if I should have done that sooner. I apologize. Okay. All right, number 10 says r to the 1 over t, which means it is the teeth or the t root of r. All right, so let's look at number 11. Number 11 is one of those problems where we're going to use a calculator maybe the first time, but then we're going to see if we can kind of figure out the pattern. So we have the 7th root of 9. Okay, the 7th root of 9. I wonder what that would be. So the 7th root, so let's see. I'm going to take, oh, that's only for the square root. Hold on one second. Okay, so to take the 7th root of 9, I'm going to hit 7. And then I'm going to hit math and go down to number 5. And that means 7th root of 9. And I get that. So approximately 1.37. So this right here is approximately 1.37. We know that 7/9 is less than 1, so it's like 0.78. Now the 9th root of 7 is going to be even smaller because it's a 9th root. So I bet the 9th root of 7 is smaller than the 7th root of 9. So the 9th root, oh, didn't mean to hit second. The 9th root of 7 is 1.24. So yeah, I had a feeling it was smaller. Now, 9 to the 7 or 7 to the 9th. Again, higher power is going to make a larger number. Lower power is going to make a smaller number. Higher root makes a smaller number. Lower root makes a bigger number. Okay, so let's try 9 to the 7th. And then 7 to the 9th. See how much bigger that is? Because we're multiplying it by itself 2 more times. So this 9, this 7 to the 9th is definitely going to be the biggest. This one right here, which is less than 1, is going to be the smallest. Then the ones where I'm taking the roots are going to be next in order. I'm going to have the 7 to the 1/9. And then I'm going to have the 9 to the 1/7. And then I'll have the 9 to the 7th. There we go. And that's my order. My fraction that's less than 1 is first. Then my roots are next. The largest root and then the smaller root. Because the smaller the root, the bigger the number. And then smaller exponent, larger exponent. Right? Let's go to number 12. Give the domain and range of the function where we're taking x to the 11/13 power. Well, when you are raising something, or first of all taking a 13th root, numbers can be positive or negative. And then when you're raising it to the 11th power, you can also get positives or negatives. So what goes in to here can be positive, negative, or 0, because you're allowed to take an odd root of anything you want. Once you take that root and you raise it to the 11th power, you could get this right here is going to make it become positive, negative, or 0. So my domain is all reals, because I can put anything in it I want. My range is also all reals. It would change if I was taking an even root. Then I could only have zeros and positives. And because I'm only putting zeros and positives in, I'm only going to get zeros and positives out. So if these were even instead of odd, my domain would be x is greater than or equal to 0. My range would be y is greater than or equal to 0. Let's look at number 13. For which of the following is the function, the nth root of x, not defined, meaning not real? Well, if x is negative and n is even, it's not real. Remember when we took the square root of negative 121? We ended up with 11i. So it's not defined when it's not real. So if x is negative and n is even. So let's see. It says x is negative and n is odd. Not that one. X is negative and n is even. That's the one we want. Okay? That would be when it's not defined. And then we get to skip this one, the one at the bottom. Let's go to the next page of the lesson master. We're going to do a little bit more of this. We're going to, again, evaluate without a calculator. We're going to do the square root of 9 and then cube it. Remember, do the root and then the power. So the square root of 9 is 3, and when you cube 3, you get 27. All right, for number 2, we're going to put the 8 in the bottom, so 1 over 8 to the 2/3, which means 1 over the cube root of 8, and then square that. The cube root of 8 is 2. And when I square that, I get 4. Okay, number 3. Rewrite the expression without a radical sign. So this would be p to the 1/5, q to the 3/5. I can't simplify either of those fractions, so I'm finished. Number 4, I have a to the 2/6. B to the 3/6. These fractions can be simplified, so I get A to the 1/3, B to the 1/2. Number 5, rewrite with a radical sign. So we are going to have the 5th root of V to the 1st, W cubed. And then number 6, let's see, we're going to need, in order to do this, notice how they both had a denominator of 5. They need to have the same denominator so we can put them under a radical sign with a radical sign, one radical sign. So we need to come up with a common denominator. So if you want to get rid of the negative first, you can, or we can do that at the end. So if you wanted to do it first, we would have r to the 1/8 over t to the 8/7. And we moved the t to the bottom in order to get rid of the negative. But I need a common denominator. And the common denominator of 8 and 7 would just be 56. So that could be r. So I'd multiply by 7 over 7 and get 7/56. And then on the bottom, I'd multiply by 8 over 8, and I'd get t to the 64/56. Okay. And then I'm going to write this using, actually, I think I took this one out on your paper. Let me just double check and see if I left this one on for you or not. Yes, I realized that I did not have this one on your paper. I'll finish it for now, but it would be then the 56th root of r to the 7th over t to the 64th. That's how you would write that. Okay. All right, let's go to number 7. Number 7 says give the domain and range where the function is f to the 5/6. Because the root is 6, we can only have positive numbers for x. So the domain is x is greater than or equal to 0. And because we can only have positive numbers, we're only going to get positive or 0 answers. So the range is also going to be y is greater than or equal to 0. And number 8, what restrictions can be placed on the function with the domain where x is x to the 9th, so that its inverse is an nth root function? Well, we want to make sure that when we have the 9th root of x, what would be the restrictions on that? Well, there wouldn't be. You can have positives, negatives, or zeros, so there are no restrictions